Hello everyone, this is part 5 of the solved questions of 17 December 2017 ISRO Scientist Engineer question paper Computer Science. So we would be discussing next 10 questions in this video. Let's move on to the 41st question. Okay, for a pipeline CPU with a single ALU, so we have a single arithmetic and logic unit. Okay, consider the following: three conditions are given and we have to tell which of the three conditions can cause hazard. Okay, so for this you have to know details about the hazard. You can go through any computer organization book so that you can go through what are the types of hazards. So let's move on to the first A option, that is the J plus first instruction uses the result of the Jth instruction as an operand. Okay, this is a data hazard because the suppose the second instruction is dependent on the first instruction, so it is a data hazard. So yes, option A should be there, that is either A should be right or either D should be there in our answer. Okay, next. Conditional jump instruction, yes, it would cause a control hazard because we have a single ALU, it would cause a control hazard. Okay, so A and B, it is again either A or D. Okay, and third instruction, the Jth and J plus first instruction require ALU at the same time. So we have one ALU. Okay, and we cannot give the ALU to two instructions at the same time. This type of hazard is called structural hazard. Structural hazard. Okay, so the option should be A, B and C, which is there, that is option D is our answer. Okay, so there are three types of hazard is there: data, control and structural. You can go in detail of these hazard from any of the computer organization book. Okay, next question. In designing a computer cache, the cache block size is an important parameter. Okay, which of the following statement is correct in this context? So we would be studying about all this. For before studying, you should know about two concepts, that is what is block. Okay, because we are talking about block size in all the options, and what is spatial locality. Okay, so because here it is in option B, there is a word spatial locality. So what is a block? The main our memory is divided into equal size segments. Okay, and these equal size segment, each segment is called a block. Okay, and data in cache is retrieved in the form of blocks only. Okay, so what is spatial locality is, if a block is retrieved, then it is highly probable that the nearby locations would be retrieved in future. That is, if a block, you have retrieved a block, so the surrounding blocks which are surrounding those blocks, they have a high probability that they would be retrieved in future. Okay, that is called spatial locality. Okay, now another thing is tag. Now what is tag? Because tag is also used here. Now what is tag? Each cache block, we have divided our memory into blocks, and each block is given a set of tag bit to identify which memory block is represented in that cache block. Suppose we have, it is just an example, suppose we have divided our memory into four blocks, B1, B2, B3 and B4. Okay, so there would be some tag bit which would identify these blocks. Suppose 00 may identify block 1, 01 is block 2, 10 is block 3 and 11 is block 4. It is like these bits are called tag bits, which are used to identify which block of the main memory is present in the cache. Okay, so now let's move on to the first. Smaller block size incurs low cache miss penalty. The answer is, if the block size is lower, then it takes less time to be placed into cache memory, hence less miss penalty, because if block size is small, so it would take less time. Okay, so it would be less penalty would be less. Okay, okay, this is okay. Second, smaller block size implies better spatial locality. This is false, because if block size is smaller, then the surrounding addresses would be also less. So spatial locality would be less. If a block size is small, there would be less number of nearby addresses for future references by the CPU to be present in the block. Hence, it is not better spatial locality. The spatial locality is not better. So this statement is not true. Now, smaller block size implies smaller cache tag. If a block size is smaller, so cache tag would be higher, because see, if the memory is divided into 1 to 4 blocks, then we have 2 bits of tag. But if the memory is divided into 8 blocks, then we would be having 3 bits of tag to identify each block. So it would be, cache tag would be higher. So it is false. Next, smaller block size implies lower cache hit time. So there is no relation between the block size and cache hit time. So more cache bits can't lower the hit time. There is no relation between them. So this is also false. The only statement which was true was the first one. That is, less the block size incurs less miss penalty. Okay, smaller block size means less cache miss penalty, because if block size is smaller, if the block is small, okay, so instead of having 4 blocks in the cache, we can have 8 blocks in the cache. So the miss penalty would be less. So our answer is A. Okay, next. Consider the instruction of a type. This is the instruction. During execution, read 32-bit word from a memory, and it stores in a 32-bit register R1. Okay, it reads it from the memory and it stores in 32-bit register R1. The effective address of the memory location obtained is obtained by adding a constant 20 to the contents of the register. Which, okay, it is like the effective address is calculated by adding a constant. It is called a displacement. Okay, and the contents of the register. So we are adding a displacement from under content. So see what can be, these are option, what type of addressing is this. So we would be going through all of them. The first is the immediate addressing. In immediate addressing, the operand is specified in the instruction itself. But here the operand is in the sum of constant and the register. So it is not an option. Okay. Next is register addressing. The operand is placed in the register. It can be of 8-bit or 16-bit, but here it is not just in the register. We are adding some displacement also. So this is not our option. Third is register indirect. In this, the operand offset is placed in any one of the registers, but it is not the offset. We are just adding the displacement. Okay, so this is not the answer. Third is the index. The operand's offset is the sum of. So offset itself is the sum of a constant, content of register R1, and a 16-bit displacement. So it is a displacement plus the content of any register. So it is D. Our option is D is our answer. It is indexed addressing. Next. A sorting technique is called stable if, okay, some of the sorting techniques like insertion sort, selection sort, merge sort, these are stable. Okay, why? Let's see. A sorting algorithm such as bubble sort, insertion sort, merge sort are stable because comparison based stable sorts such as these sorts maintain a stability by ensuring that the element AJ, that is AJ, always comes before AI. That is AJ always comes before AI. If J is less than I, J would always come before I while sorting. Okay, and if J is less than I, it would always come before I if A of J is, that is, if A of J is less than A of I. You remember, you understand what? If we have two elements, 2 and 6 in our sorting algorithm, then 2 would always come before 6. Okay, and if you have two equal elements, 2, 2 and 6, sorry, if you have two equal elements, 2, 2, so and I is there and J is there, so it would compare the index. This 2 would come in front and this 2 is come backward. That is, it would maintain a relative order of occurrence. Okay, so the answer should be C. It is stable algorithm means the algorithm where the relative order is preserved. Is that type of algorithm is called a stable algorithm. Okay, so this is the answer C. Next, match the following and choose the correct answer in the table. Okay, we all know that heap construction is order of n, and maintaining heap property, sorry, for heap sort it is n log n, order of n log n, okay, which is made up of order of n plus order of log n. Sorry, order of n into order of log n. It is like this. The order of n is heap construction and order of log n is heapify, maintaining the property of heap. So for heap construction it is order of n. Okay, this is true. Okay, now hash table construction with linear probing it is order of n square. Okay, and for AVL tree construction it is order of n log n. Okay, so the answer should be RQP. RQP is the D. D should be our option. Okay, this was a one-dimensional array representation of a rolled triangular matrix of size n cross n. So okay, we have a rolled triangular matrix of size n cross n. For example, we would be having a 3 cross 3 rolled triangular matrix. Let the rolled triangular matrix be, it is 1 0 0 2 3 0 and 4 5 6. So this is a lower triangular matrix. The elements above the diagonal are all 0. It is a 3 cross 3 row triangular matrix. Okay, of size n cross n, and non-zero elements of each row are stored one after another starting from the first row in an array. Okay, let's see, the non-zero elements are, that is 1. They are stored one after the another like this. Okay, so we have to calculate by using the I and j of this. We have to calculate the index of this. It is a one-dimensional matrix, so we have to calculate the index of this. Okay, so for calculation we can be the matrix can be starting from 0 also, 0 0 also, or it can be starting from 1 1 also. So first we would be considering the situation 0 0. For 0 0 here would be 0 1 and 2, here would be 0 1 and 2, here it would be 0 1 2 3 4 and 5. Okay, so now it's just a hit and trial method, it's the easy one. Let's consider for index 0 0 first. If we are starting from 0 0, so let's take arbitrarily number 5. Okay, so for 5 here the index of 5 is 2 comma 1, so I is equal to 2 and j is equal to 1 for 5. If we are taking 0 0, for 5 it is 2 comma 1. Okay, and in this array, let this array be x. In this array, x 5 is equal to x of 4, that is 4. That is, if we put 2 and 1 in any of this, the answer should be written in 4. Okay, so 2 plus 1 is 3, so A is not an option right now. Okay, here if I put here, it is 1 plus 2 into 2 minus 1 by 2, it is returning 1. So for now this is not my option. Next this, it is 2 plus 1 minus 1, it is 2, it is not returning 4. Our answer should be 4, because at 4 only 5 is there. Here if I put this, it would be 2 plus, it would be 2, because it would be 0 by 2. So this is not also answer. So we are not considering the case 0 0. We would be considering 1 1. That is, our matrix is starting from 1. So it is 1 2 and 3. It is 1 2 and 3. So here also it would be, I'll cancel it up, it is 1 2 3 4 5 and 6. So let's, for 5 only we will be take. For 5 in this case, now I would be 3 and j would be equal to 2, and x of 5 is x of 5. So I should get answer 5. Okay, by putting 3 and 2. So here if I put 3 and 2, I am getting 5, so I can consider this. If you put 3 and 2 here, I am not getting 5, so this option is ruled out completely. If I am putting 3 and 2 here, 3 plus 2 into 2 minus 1 is 1 by 2. It is not. So this option is completely, these option also completely ruled out. And this, if I put a j plus j is 2. 2 plus 3 into 2 by 2, it is giving 5. So we would be considering options A and B. Okay, this is for 5. So let's check out one more example so that we can rule out any one of these. So let's take 1. I'm taking 1. So for 1, I is equal to what? 1 and j is equal to 1. Okay, and x of 1 is 1. So the answer should be 1. But if I put 1 plus 1, it is 2. So this option is ruled out because 1 plus 1 is equal to 2. But I want 1. Here I will be putting out 1 plus 1 into 1 minus 1 by 2. So it is giving 1. So answer should be B. B is the answer. Okay. So this, like this hit and trial you can try. B should be our answer. Okay. Next, 47th question. Which of the following permutations can be obtained in a same order using a stack, assuming that we have a sequence, stack sequence is this, but we have to solve it. Which of these sequences, which of the following sequence can be obtained? So let's see. We have a stack. I pushed 5 onto the stack, push 5 onto the stack, and I push, because we have, see, 5 is here, only 5 is there. If I want to pop 5, I will be popping 5 over here, but 5 cannot be popped at first because after 5 there is nothing here. Okay, then I pushed 6, so 6 is not starting anywhere. Then I pushed 7, 7 is pushed. Now what I'm doing is I'm popping 7. So our letter sequence is what? It is push 5, push 6, pop 7. So I popped 7. Okay, and push 8. Okay, so popped 7 means these two. Okay, and I popped push 8. Sorry, push 8. Now pop 8. Okay, push 9, because in this sequence after 7 we have to push 7, after 7 we have to push 8, after 8 we have to push 9. So 9 is at the top, so push 9. So pop 9. So we have 7, 8 and 9 popped, but see, 5 cannot be popped until 6 is popped. So first 6 would be popped, then 1, then only 5 is popped. So this condition is ruled out. Okay, so the answer is this. The 6 would be popped first and then 5 would be popped. So there is a shortcut for this. Let me tell you, for this we have to check every sequence. For example, in this sequence we have, see, this is all in increasing order, that is 5, 6, 7, 8, 9. So what I would be checking is 7 is there, yes. 7 and 8 are consecutives, no problem. 8 and 9 are consecutive, no problem. So I will be talking about the index. I'll put some index over here. Okay, so 7 is consecutive to 8, no problem, and 8 is consecutive to 9, no problem. Till now there is no problem. 9 and 5, they are not consecutive number, but the index is decreasing. 9's index is 5 and 5 index is 1. So index is decreasing between 9 and 5. Index is decreasing. So between 9 and 5 we have how many numbers? We have 1, 2, 3 numbers. Okay, that is 6, 7 and 8 are present between 9 and 5. This is how we have to check. 7 and 8 has already occurred, has already come, but 6 hasn't come. So this is invalid. So this is how we can check. Let's take another example from this. See, suppose we have this, we have 5. Okay, 5 is at index 1, it's okay. And then we have 9. 9 is at index 5. Okay, so between 9 and 5, we have what? We have 6, 7 and 8, and none of them has been pushed into the stack, has been popped. So this is also invalid. Okay, let's take this one. In this we have 9 and 8. Okay, and between 9 and 8 there is nothing, so no problem. We have 8 and 7. Between 8 and 7 we have nothing, no problem. And we have 7 and 5. Between 7 and 5 we have 6, but 6 is not here anywhere, so it is invalid. Okay, let's check our answer. We have 7. Okay, 7 and 8 are consecutive, no problem. 8 and 9 are consecutive, no problem. Between 9 and 6, 9 and 6 they are not consecutive, but between 9 and 6 we have two numbers, 7 and 8. 7 and 8 only there between 9 and 6, and 7 and 8 has already occurred, so no problem is there. And 6 and 5 are consecutive, there is no problem. So this is only the valid sequence. So this is a shortcut, you can check it like this. Okay. Okay. This is the next question. Quicksort is run on two inputs. Okay, it is run on two inputs, that is 1, 2. It is increasing order or it is a decreasing order. One is the ascending order, one is a descending order. Let C1 and C2 be the comparisons made for A and B respectively. Okay, actually this question is incomplete. There must be a statement that first element is taken as a pivot. First element is taken as pivot element. Okay, so the answer should be B, because whenever the first element in every step of Quicksort, a number of divided as per the following, that is Tn minus 1 into order of n. It is for all cases. So when the first element is the pivot element, the complexity would be same for all. The C1, the number of comparisons would be same even if it is ascending or descending, if the array is sorted, for sorted arrays. Okay, so it would be C1 equal to C2. Okay, next question. A binary search tree is used to locate number 43. Which one of the following prop sequence is not possible? So for this, what we would be doing is we would be constructing the binary search tree for all of them, and we have to remember the property of binary search tree. The left side lesser number and the right side is greater number. Okay, this is the property of binary search tree. For A, first I would be making a binary search tree to check. So I will start with 61. I have 61. Okay, 52 is lesser than 61, so I will be writing 52 over here. Okay, 14 is lesser than 52, so 14 over here. So we not possible sequence. So we have to find a sequence which is not possible. 14. And next is 17. It is greater than 14. So on the right side of 14 would be 17. 40. So how we have to check is 40 is greater than 61. 40 is less than 61. So here left side of 61. 40 is less than 52. The left side of 52. 40 is greater than 14. So right side of 14. 40 is greater than 17. So right side of 17, and next 43 is greater than 50. 43 is less than 62. 43 is greater than 14. 43 is greater than 17. 43 is greater than 40. So yes, this sequence is possible because by traversing 61, 52, 14, 17, 40 and 43, this sequence is possible. So let's make a sequence for B option. So I'll start with 10. 65 is greater than 10. Okay, 31 is greater than 10 but it is less than 65. 48 is greater than 10 but it is less than 65 but it is greater than 31. 37 is greater than 10, less than 65, greater than 31 but less than 48. Okay, and 43 is greater than 10, less than 65, greater than 43 but it is greater than 31 but it is less than 48, less than 48 but it is greater than 37, so it would be here. So yes, this sequence is also a possible sequence, that is 10, 65, 31, 48. By traversing this we can see, let's see the C1. We have 81 over here. 61 is smaller than 81. So it is like this. 52 smaller than 81, it is smaller than 61. 14 which is smaller than both. 14 is smaller than both, so 14 would be here. Okay, 41 is smaller than 81, 41 is smaller than 61, 41 is smaller than 52 and 41 but it is greater than 14, so 41 would be here. Okay, next 43, it is 43 is smaller than 52, 43 is greater than 41. 14 So it would be here, it is 43. So this sequence is also a possible sequence. Okay, by traversing this we can have, let's see the D part. We have 17 over here. Okay, 77 is greater than 17. Okay, and 27 is greater than 17 but less than 77. 66 is greater than 17. It is less than 77 but it is greater than 27. 18 is greater than 17 but it is less than 70. It is less than 27 also. So it would be here. Now next is 43. 43 was greater than 17 but it is less than 73. So it would be over here, but it is greater than 27. So it would be over, but it is less than 43. So it would be over here. So for searching 43 over here, we would be traversing 17, 77, 27, 66 and 43. 18 would be left out. So D is our sequence which is not possible. So let's move on to the next question, 50th question. The characters of the string, okay, these are inserted into a hash table of size using hash function. Okay, this question was not used for evaluation in the ISRO paper because there is a mistake. There has to be a statement like mod 10 over here. Now this question is right. And there should be option J also, but it is okay. This is the question. Okay, now let's solve this question. So okay, we have 10 places. Okay, so we would be having a hash table like 0 to 9. Okay, what this order of A means, it is order. ORD means it is order. Order means if A is equal to 0, we can take it as if A is equal to 1, then B is equal to 2, and then C is equal to 3, and so on. Z should be equal to 26. This is what this order means. So we have this order over here. A is equal to 1, B is equal to 2, C is equal to 3, D is equal to 4, and so on. This is what the order means. Now let's fill this. For the first, that is for K, order of X. So this is X, this is our X. Okay, so H of K would be order of K. What is K? K here is 11. K here is 11. So we would be putting it as, for K, it is equal to 11 minus, what is order of A? Order of A is 1. Okay, plus 1 mod 10. So 11 mod 10 is 1. So K would be placing it over here. Okay, now let's check for R. For R, order of X is 18. Okay, order of A, yes, it is 1 plus 1 mod 10. So R we would be placing it at 8. R would be placed at 8, sorry. R would be placed at 8. And for P, similarly, P would be placed at 16. 6, sorry, P would be placed at 6. And C would be placed at 3. S would be placed at 9. Okay, and N would be placed at 4. Y would be placed at 5. Y is 25, so it would be placed at 5. T is 20, so T would be placed at 0. Okay, now we have J. J is also placed at 0. So for J we have collision. So J should be in our option, but it's not there. Whenever there is a collision, we would place it at next available location. So next available location is the 2. So J would be placed at 2. Next we have M. M should be placed at 3. So for J and M we have collision. So next available position is 7. So there it should be M. So answer should be J and M, but here M is only there, so it should be C. So C is our answer. So this was all about the solved question papers for question 41 to 50. If you like the video, please don't forget to subscribe and please like the video also. Thank you.